and I will be your co-host for this session. And this session is in association with the Ontario Regional Malayali Association, and this session will also be recorded. Okay, so today we'll be talking with Dr.Bhairavi Shankar, who is a planetary scientist. She's also the founder and CEO of Indus Space, which is based in the Greater Toronto Area. She's also the chairperson of Lotus STEM, and she'll be talking to us on the topic of why go to Mars today. Okay, before we start, I'd like to say if you guys have any questions during the presentation, please type them in the chat, and we will try to answer as many as possible during the Q&A session at the end. And now, without further ado, I will pass the virtual microphone to Dr. Bhairavi Shankar. Everyone give her a big round of applause.
Hello, everyone. I'm so excited to meet all of you virtually. Thanks to organizers for inviting me. I'm super excited to talk about Mars. I love talking about many things about space science and what we know about different parts of our solar system. But for today, we're going to focus on Mars. So as Safal mentioned, if you have questions, type it away in the chat window. And once I'm done my part of speaking, I'm more than happy to take everyone's questions. I will say that there is so much about Mars that we can really talk about. And each of these topics could actually be its own talks, but for just for getting everyone around the understanding of why we are even exploring Mars, I thought I'd put this sort of intro together, and I will keep an eye on time so that I don't talk for too long. So let's get started. Okay, so journey to the red planet. Did you know back in about 1600s, so many centuries ago, there was an astronomer named Christian Huygens. He had a telescope in his, study area, and he was looking up at the night sky, and he happened to see Mars. He knew that it was Mars, but you know what? With this telescope, it was a new instrument, and he was like, I want to go and see it a little closer. Let me see what I can observe. And what happened was he started to make drawings. This was at a time when there wasn't internet. There was no social media. There was nothing like that. So a lot of the time when there was, after work or after sunset, they had a lot of astronomers, or people in general had a lot of time to look up at the night sky. And so Christian Huygens started to make observations of what Mars looked like. And these are some of his early drawings of what he was observing. There were some smooth areas, but in general, there were these other rough areas. And he had 3 different distinct pictures that we are looking at right now. Fast forward now to 20th or 21st century, so 1900s to now, what we are in 2021, we have now sent so many missions, and it has been actually possible for us to go back and compare what we see from missions to what he observed in his drawings. And there are quite some similarities. There are these areas where he thought of them as being rough. And actually, these are certain sections on Mars's surface that have had either some tectonics happening, a lot of cratering, but there's also some general coverings from sand. And this was the neat thing to see that over 400 odd years, we've been able to actually look at early observations and then start to confirm what they might be, and help us understand Mars a little more. Mars has also really been very popular in our pop culture. So on the left, there is a picture of what there used to be a really old radio show. So again, before TVs, we used to get our entertainment through radio. And there was a radio show called War of the Worlds, where they were sort of having a storyline where aliens from Mars were coming and going to land on Earth. And this caused so much mass hysteria around people. But that also made people really curious. What is it that we know about Mars? And then what's on the right? It's a picture or a screenshot from the movie The Martian. Quick show of hands. How many have actually seen The Martian? Do you want to use your reactions or maybe even just give a thumbs up? No, no one has. Okay, that's fine. Wait for a few more years. I'm seeing some. Oh, okay, some have. It is a story about an astronaut who gets stranded on Mars, and he's trying to figure out how best to survive while he's waiting for like others to rescue him. And it's a pretty. There are quite some movements and simulations, but otherwise there were aspects of this movie that were pretty much like, if we want to send astronauts to another planet, we have to think about some of these things, like how are we going to get them in a safe area to live, or how are they going to depend on the food? Are we going to send it all from Earth, or are we going to get maybe to grow something on Mars? And so there's so much interest in pop culture and just in general about space exploration. We have learned a lot about living on Earth. If we want to go somewhere else, where's the next best place? Mars. So this is now a sort of family portrait. You can think of looking at Mars and then seeing, what have we sent? Almost every year, there's almost a news that there is a new mission going. But if you look at it over about 50 years or 40 years, there have been many, many missions. Many countries have sent it. So Russia is one, USA is another. They're the ones who have maybe sent the most, but they're not the only ones. There are some countries from Europe. There is India. There is now recently United Arab Emirates, right? So there's a whole group of countries who have all sent something or attempted to send something to Mars to go and explore. Now, I will say, while there are many of these on this picture, not every one of them have been successful. There has been about a 40% chance of success, but nonetheless, they would still learn something. Even if a mission wasn't successful, the teams learned something so that they can then apply that for the next time. And then maybe it got successful. So there's a lot. I'm going to talk about a little bit of what we have seen from each of these missions, but we have explored a lot of Mars. What do we know about Mars? It's the fourth planet from the sun. It's the one that looks the most like Earth. It has a lot of topography. I'm going to have some other pictures that show up. It has the largest volcano in our solar system. That's called Olympus Mons. Olympus Mons is about 24 kilometers high. So question, if you want to write in the chat window, what's the tallest mountain on Earth? And if anyone knows what that height is, write that down. But in the solar system, Olympus Mons is the winner. We also have what's called like a trench. So you can think of it like a huge tear on the surface. And that tear is actually on Mars. It's really long, about 4,000 kilometers, and it gets pretty deep as well. So it's about 2 to 7 kilometers deep. You could think of it like the Grand Canyon of the solar system. How many have heard of the Grand Canyon on Earth, right? Maybe before pandemic, we might have visited the Grand Canyon, but you can think of Valles Marineris as a similar idea. There's a tear, but then that tear got bigger because of water and wind and all of that movement that made the rocks actually break apart. Then we also know that right now, there isn't any life on Mars, like whatever we may think of as life. But the way that Mars was many billions of years ago, there is evidence that there was water before. And it's just not possible to see that water free flowing on the surface now. It's kind of trapped in all the rocks. I mentioned that Mars is very much similar to Earth, but this is almost like a side by side of how does Mars look compared to Earth. What's the first thing that comes to mind? Mars is pretty small, right? It has a very small surface area. It's smaller in general compared to Earth, but there is still a lot of curiosity and a lot of excitement that we want to keep going and exploring, and we want to go and eventually land on Mars. So what do we know about Mars today? What you're seeing in this picture on the left is that really, I'll find my mouse. This part is that rift that I talked about, Valles Marineris. So there's that part. And then there are other parts of the surface of Mars where there are maybe circles. How many have heard of impact craters? It's this process and this feature on the surface that forms when you have a space rock. I'm seeing a few hands up. That's great. A space rock that comes and hits onto a surface, and there's so much energy that is being transferred in that process that it essentially digs a hole. And on Mars, we're seeing a lot of that happening. So every circle that you see is caused because a space rock came and hit on Mars. I will mention that space rock hitting on Mars, it's not only on Mars. It happens everywhere in our solar system. But for today, we're going to just look at it on Mars. What are other features that we see on Mars? We're seeing rocks. There's a lot of hard like crust. We're seeing landslides. We're seeing a lot of like rocks and soil that kind of caved in. It got like moved because there was some force on it or some pressure or some movement because of water. Landslides happen when there's a lot of fast flowing water. Then there are craters. I mentioned about these space collisions. There are valleys. There are volcanoes. And then there are evidence of like water just moving around, maybe like channels or like deltas. And then you're also seeing evidence of wind having broken down the rock. So if you have been to the beach, maybe you've seen rocks that are nicely rounded. That's because the wind has been kind of chiseling and like making it super smooth. You're seeing all of that evidence even on Mars. So why do we want to go explore Mars? You might wonder. Well, the first question is, was there ever life? When I talked about Christian Huygens, that astronomer from 1600s, ever since then, anyone who has explored Mars has looked at it and thought, those look like canals. Like they called it canales because originally they were seeing features that looked like river streams, and they were like, oh, there's water. That's the only like explanation. We've seen this on Earth. That's what we assume is happening on Mars. And that has always been the number one reason why everyone is excited to explore Mars. So if you see water, what do we know about water? It tends to have some form of life. And this is where those early questions came up. Is there life on Mars? So they wanted to go and explore, and every mission that has gone to Mars has gone with this first basic question. Can we find evidence of life? They also want to go and explore Mars, or we want to go explore Mars because we want to understand the climate. I mentioned that Mars is pretty small compared to Earth, right? But Mars also has dust storms. There is a thin atmosphere, clouds form. We want to understand, what does that mean? How hot or cold can it get on Mars? Are there ice caps? Yes, there are. What are they made of? What is the geology of Mars? So all of the rocks, maybe you're seeing in the picture behind me, there are a lot of rocks. And we know on Earth, if there are rocks, they could be hard, they could be crust, they could be molten lava that then cools down, or they could be things that were affected by the water. So it kind of got, there was original rock, but then water kind of changed it up a little bit. So that whole area of studying rocks is known as geology. We want to know what's the geological history on Mars. And then finally, the other reason is that first question that I mentioned about wanting to go and explore. As humans, we have explored a lot of Earth, but we're like, where else can we go? First, next best place is the moon. I will mention the moon is the next possible place. But Mars is the sort of ultimate destination. And so if we want to go and explore and send humans to Mars, we kind of need to know, where's a safe place to go? Where can humans stay? Where are humans going to get their food or water? So if we can understand what is all needed to get that going, then it's easier for us to say, okay, let's go and send humans, and we'll go and explore all of this. Hopefully this makes sense. This is why we want to go and explore Mars. How do we go and explore Mars? Even whether it's humans or before humans get there, what's the best way to go and do it? There are 3 different kinds. You could send a flyby. What that means is, think about a satellite. You've launched the satellite. and you're saying, satellite, go out to Mars. As you're going past Mars, I want you to take photos and tell me what Mars is looking like. That's one option. That's called a flyby. The other option is maybe an orbiter. So you send the same satellite up, you send it to Mars, but this time you're going to tell it, once you reach Mars, just keep orbiting. Keep going round, 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 round. And every time you're going around, you're going to take photos, you're going to take images, and you're going to send it back to us. Mission control is going to see it and figure out what's happening. So that's the second type. Then the third type is a lander. You now want to go and like not just orbit from space and look down like a bird. You want to go down there, you want to land, and you want to explore, because you can be a geologist, a robotic geologist. You'll have all your tools and you'll go and explore the rocks, you'll pick it up, and you'll help address any of those questions that I just asked before. So what are some of the other past missions that we've sent? We first sent the first successful mission back in 1965. But then every few years, there have been more missions. One that maybe just took photographs of the surface. Another one that not only took photographs of the surface, but had instruments to help understand the weather. Then we sent our first rover, Sojourner, in 1997, so about 24 years ago. It was the first one to have wheels to move around and kind of drive around and tell us a little bit about what the surface looked like. Then we had Phoenix. Phoenix was a bit special for us in Canada because we had an instrument on there that was also looking at the weather. So it was the first time like a Canadian team was participating in exploring Mars. But that was the before. In the last like 20 years, we've explored even more. We've sent a combination of orbiters, those satellites orbiting, or we've sent rovers. So how many, again, show of hands or reactions, how many have heard of Spirit or Opportunity? Those were two rovers after, yeah, I'm seeing a few hands. Few rovers that after Sojourner and Phoenix, those were the next set to go. Spirits, and you know what? Those were only meant to last for 3 months. They lasted for between 10 to 14 years. So that's already telling you just how much effort and precision the teams did and in putting together instruments that were lasting longer than 90 days. They could last like 10 years. Imagine what happens in 10 years. There's so much that you can learn. So Spirit did that, Opportunity did that. And then there was an orbiter called Mars Reconnaissance Orbiter. That's actually still active. It's a satellite that's orbiting, and it has so many instruments that are so much in high detail. It's able to, do you see this picture over here? That picture is, think about it. It's the Mars Reconnaissance Orbiter. It had a camera, and that camera is called HiRISE. And basically that camera was able to pick at the exact moment this parachute was coming down as the Curiosity rover was making its way through the atmosphere about to land. So this is like a little snapshot that the orbiter took saying, aha, I spot where it is. And that little white part in here is the heat shield that inside of all of that was Curiosity, the rover. And eventually we know Curiosity landed. That's the picture on the right. And Curiosity has been exploring for about 8+ years. So there's so much, like you may be thinking about, why are we sending all of these? But in some ways, each one is kind of part of a jigsaw puzzle. It has some instruments. It's telling us a little bit of information, but that information is going to help us when another instrument and another lander is going to explore Mars. Does that make sense? Hopefully all of this is making sense. Okay, I'm seeing a few head nods. In the last year, we know, well, actually after Curiosity, we also know India sent our first mission, which was Mars Orbiter mission. Did really well. And again, for a new country to join this whole like journey as a global community, it was celebrated because everyone was like, aha, there's another country who can do this. And if you look at last year, we sent out Perseverance. Maybe that's another name that you have come across or you've heard of in the news lately. And then even in this last like few months, we had the United Arab Emirates who sent a mission called the Hope mission. We had China who sent another mission, an orbiter called Tianwen. And then there's more planned, right? Like it's not that it's the end of it. Each of these missions have been kind of telling us a little more. InSight, for example, back in 2018, it left or it reached Mars. It's a lander. InSight is a lander that is actually now looking for Mars quakes. We've heard of earthquakes, right? Like earthquakes happen on Earth. Guess what? This instrument is trying to figure out, do quakes happen on Mars? Why does it happen? How is it happening? Does Mars have more than one tectonic plate? No, it just has the one plate. What does that mean? How stressed is that, like that surface? All of that is, each of these instruments have something to tell us. Okay, so I've been setting up the scene of what these missions are. But what has it told us about the interior of Mars? So Mars, from the top, if you look at it, we have a crust. It's rich in rocks that have aluminum, silica, kind of like what we see on Earth. Then below the crust, we have a mantle. The mantle, you can think on Earth, we have the mantle that has lava, magma, right? Magma, because once magma comes onto the surface, that's known as lava. Same idea even on Mars. It's just smaller, but it still has the same sort of structure. So we have a mantle. And then we have a core. The core is pretty much iron rich, but there's also some sulfur and maybe some oxygen. So this is the layers of Mars. Kind of similar to Earth, but yet it's its own thing. Some of these missions and satellites have now actually given us such a global view of what the topography looks like. So by topography, I mean elevation. How high or low are the surfaces on Mars? And already, what can you say? That on the left, there is some colors. On the right, there are similar colors, but it looks different, right? The colors are telling you how high or low things are. So if you find anything that's in the blues, the cyans, or the purples, that means that it's lower than a base. So you can think of it, if you were at a swimming pool, if you were standing at the edge of the pool, think of that as your base. If you're inside the pool, it's lower, right? And that's what these sort of blues and cyans are telling you. You're lower than the base. But then there are the reds. The yellows and the greens are kind of, again, at our base. Those are average. And then there are the reds. The reds means you're going uphill. So maybe you're approaching like really rocky mountains, or it just happens to be that it's very much higher in elevation. So this map was really the first time you could see Mars from a global scale and kind of figure out that there's so much difference. It's not like on Earth where you have the continents and the oceans. This has its own sort of history. And that really piqued everyone's interest because they're like, what is happening? Why is it like this? So I'm unable to see the chat window, but maybe you have questions or you're like, what's happening over here? So what I've done is basically taken that original sphere of the elevations, we have flattened it and made a map. So what does it show now? Same idea. The map is now showing that you have this dotted line. Basically, you can think of the dotted line as the sort of equator, or the range at which anything above the dotted line, you're part of the northern areas, hemispheres, right? So northern, and anything below that dotted line is southern hemisphere. And so if I can't see the chat, but I'm going to assume that you are already starting to make some pattern recognitions. If you look to the north, it looks pretty flat, or it actually looks pretty low because there are all of these blues and like light blues, right? But as you make your way towards the equator, and actually as you make your way towards the southern parts, it is actually, kind of going uphill. You're having some basic elevations, but then if you go out here, there's quite a bit of rough terrain. It's higher than usual. So what's happening? Why is there that sort of distinct breakdown between northern parts being super low, but then the southern parts being super high? The exception, of course, is in this, sorry, I'm trying to find my mouse, this area. And if it's not quite obvious, it might be in a few slides, but this is already telling us something else is happening in this region. So this got scientists and engineers super curious, but it also makes it really helpful to know if we want to go and send a lander, this kind of a map is going to help us understand, is where we want to go going to be smooth, rough, rocky? Is it going to damage our lander, or maybe not, right? So this is one of the reasons why this sort of a map really helps us, because it helps us know where are we going. We want to avoid, hitting onto a rock. And so this sort of a map will help us with that. Okay, so this is just a same map, but now it has some dots. The dots are telling us where some of these missions where we landed have actually landed. So you're already maybe seeing that we have landed on different parts of Mars. So Phoenix, the one where I said like Canada had our first instruments, it landed up in the northern parts, in like close to the poles, but it was in the northern flat areas. If you look at Opportunity and Spirit, Opportunity is somewhere in the middle, like in the middle plains, but it's on one part of the planet. Spirit, its twin, went into a completely different part of the planet, right? So that's Spirit. I talked about Perseverance, the current mission. That's at Jezero Crater. I have a few slides that are going to show what Jezero Crater looks like, but you can see that's where that has landed. And InSight, the one that's looking for the Mars quakes or understanding Mars quakes, have actually landed a different spot. So even if we've sent so many missions, each mission has gone to a different part of the planet. And you can think of it again as another jigsaw puzzle. It's kind of telling us a piece of what's happening in that region. Hope that makes sense. Okay. So I talked about Olympus Mons, and really, if it wasn't too obvious, this large feature in the corner is Olympus Mons. It's a volcano, or from the top, it might have looked like a mountain, but that's where Olympus Mons is. You can see that there is some sort of, think about it, the volcano would have erupted early on, and some of that lava has kind of gone around it and flown out, and that's why you have that little change in elevation. It's gone from super high to about middle to then low, right? Does it make sense? Like a slope part? So that's what you were seeing. I mentioned Olympus Mons is 24 kilometers high. This is a sort of a side view of how Olympus Mons compares to Everest or Mount Everest, so which is in Nepal, or Mauna Kea, which is in Hawaii. So they're all pretty tiny compared to what Mauna Kea, compared to what Olympus Mons looks like. So that's already giving us like, oh my gosh, this is such a huge volcano. Quick picture views of what the surface of Mars looks like. Everyone has heard Mars looks red. That's right, because it has a lot of that aluminum silica, but it also has a lot of that iron that might have gotten released from the core onto the surface thanks to this volcanism. So because of what happens to iron, when you leave it out for a long time, it starts to rust. And that's what is giving that reddish color. And that's why a lot of rocks on Mars gives that red tinge. But otherwise, it looks like, if you were out in the desert or something, you might think you were on Earth, but really this is pictures from Mars, which is why one of those reasons why Mars and Earth are thought to be very similar. Atmosphere. So Mars has a thin atmosphere. It's not so on Earth, we have an atmosphere that's about 100 kilometers thick, but on Mars, it's maybe about 10 kilometers thick. So not that thick. But it's also, Mars's atmosphere is very rich in carbon dioxide. There's some little nitrogen, some argon, but otherwise it has a different sort of composition of the atmosphere, and it can get pretty windy. So there are dust storms on Mars that will, at sometimes it has covered the entire planet. So for us on Earth, if we were looking with our telescopes, Mars may have that sort of features that, you know, Christian Huygens saw, like with differences, dark areas, light areas, etc. But when a dust storm happens, it kind of makes everything look red. You can't even start to see those features, which is interesting. Sometimes it has actually not helped with the rovers. I think Spirit or Opportunity, sadly, the end of Opportunity happened because there was a huge dust storm that covered much of the planet, and Opportunity had solar powered batteries, which meant that it was dependent on the sun. If you can't see the sun during a dust storm, what's going to happen? That battery is going to kind of go dormant. It may actually not even work when the suns come back, right? Like if it doesn't have enough charge. So that's what sadly stopped Opportunity. Hang on. Ooh, I'm seeing a lot of things. I'm seeing 61 notifications. I've not opened it up yet, but okay, I'm glad to see there's quite some active chatter happening. So Mars's atmosphere, the picture on the right, if you're seeing a GIF, or if you were seeing a GIF, that was from the Phoenix mission. It happened to look up at it had cameras to look up at the sky, and it was able to see clouds forming. It was able to see some snow falling, and this was exciting to say, hey, yeah, and things like this happen on Earth, but now we're actually seeing it on another planet. Polar ice caps. The northern and southern tips of Mars have these ice caps. Unlike on Earth, these ice caps are not just water rich, they're also having carbon dioxide. Sometimes the ice cap can grow, but sometimes it'll also shrink depending on the seasons on Mars. So again, cool things that happen. The last thing that I'll mention is about the moons of Mars. So we have one moon, our own Earth has our moon, but Mars has two moons, Phobos and Deimos. And what's the first thing that you see? These are pictures of those moons. Phobos on the left, Deimos on the right. And both of them are not fully nicely spherical, right? Like we know of our moon, it has nice round edges. There are bumps and, you know, craters, etc. But Phobos and Deimos, they kind of look like odd shapes. Scientists have been trying to figure out what is the history of this? How did these moons form? So chances are, the leading thought is these moons are actually asteroids that got pulled in thanks to Mars's gravity. So it happened very early on when Mars was sort of young, but it pulled them in, and now ever since then, Phobos and Deimos have been orbiting around Mars. And I believe Phobos is the one that's actually moving in even closer to Mars, but it's a very minute, like detail, little like millimeter every few years kind of a thing. So nothing's going to crash just yet, but it's also interesting to see that they're kind of, they've been orbiting Mars. So I'm almost towards the end of my talk, but I want to kind of spend a few moments talking about Perseverance, because that is the most recent rover that's out on Mars, right? Like it's exploring. So this got launched last year, and it took about 7 to 9 months to reach the surface. This is how the actual rover looks in animation. So this is a cartoon representation, but it's very similar to Curiosity. If you look at both the rovers side by side, both have 6 wheels, both have some instruments. They have a head, like, you know, the head part, which you can see over here. The head has some instruments, and then it has this extendable arm. It's a robotic arm that'll really help grab some samples, maybe take some drill something into the rocks. It's all similar to Curiosity. But the neat thing is, Perseverance has a few more extra instruments that Curiosity doesn't. One of the instruments is MOXIE. So the one that you're seeing at the very bottom, like bottom front. MOXIE is this instrument that'll help take in the carbon dioxide from the atmosphere of Mars and change it up so that it releases oxygen. And guess what? Why do they have this? It's because if they want to send humans to Mars, humans need oxygen, right? Like, what's carbon dioxide going to help us? We need oxygen to survive. So this instrument is actually helping teams understand, can we take carbon dioxide and exchange it and get oxygen? If it works, perfect. Then when we send humans out to Mars, we don't have to send them with cans and cans and cans of oxygen from Earth and imagine it has to be launched. None of that has to happen. Instead, what we could do is actually just extract oxygen from Mars's atmosphere. It helps reduce the load that we have to send with the humans. One of the other things is that it has a weather station. Good to know what the weather's like on Mars. And things to also kind of know what the compositions are of the rocks on Mars. Each area is different. If you've had some space rocks hitting and forming a crater, that tells you a little more about what does Mars's surface look like, what are the rock types, etc. And if we want to send humans, where should they go live? Because you can imagine if you're sitting on or standing on the surface of Mars, it has a thin atmosphere. That means solar radiation from the sun will be a bit more stronger. On Earth, it's not as strong because we have our atmosphere to protect us. But on Mars, we have to figure out how best to protect humans so that we don't get like zapped because of the solar energy. We have to figure out where are good spots to go and stay. So I showed you where Mars 2020. So Jezero crater, that's the area where Perseverance has landed. This is how it looks like in general picture. If we were to see with our own eyes, this is how that crater looks like. But remember, I showed you topography maps too, right? This is how topography looks like at Jezero crater. So you're kind of at the edge of that higher area, but as you go inside the crater, that elevation is dipping. So you're kind of going down into a bowl, basically. And in that area, in general, but Jezero crater is a small crater in that bit of a transition. So it's a neat area because we're able to sample rocks from all around. There might be some history that it's telling us as well. So this is why Jezero crater was picked up. That's there. Yeah, so you can see where it is relative to other features. I'm going to show this video. So if you haven't seen this, this is a very exciting video that just got released when Perseverance was landing. So this was the, hang on. You know what? I'm going to stop sharing my screen and actually making sure that you can hear audio because there is audio. It's about a 3-minute video. Let me see. New share sound, share.
Parachute deploy and to roll over to give the radar a better look at the
Can you
ground.
Yeah, okay.
Yeah, we can hear.
Indicate chute deploy.
The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
So these are cameras on Perseverance as it was landing.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation, and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
LVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Oh, hopefully it'll come back. But if not, I'll share the video link and then you can also see it after. I think it might be my internet. Apologies. Oh.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
So this is the point
Sky
when
crane maneuver
the
has
crane
started.
was releasing and it was sort of dangling down
20
and
meters off the
about
surface.
to like release it.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
Okay, so I will share this video as well and you can see it again and so share it with your family. So one of the things that I'm going to end off with is actually to say, if you're curious about Mars and you want to go and explore a little bit right from your home, there are a few ways to do it. So the first thing is I would recommend you can install or ask your parents and install Google Mars on the desktop. So not the internet version, but actually install it on your desktop. And once you do that, you are able to actually change it up from seeing Earth to now going and seeing Mars. And one of the things is you can change and see how that elevation also looks like, and you can pan around and go into specific areas and start exploring. So if that's something that you want to try out, definitely recommend it. It's super easy. And just a heads up, if you are trying to open many images, it'll slow the system down. So really think about what you want to turn on, but you can start to explore Mars. One of the things that I've shown about Curiosity a little and a bit of Perseverance, if you want to kind of follow along on their journeys, there are websites on both NASA pages that kind of tell you where the rover is. So this is for Curiosity. It is, it's the link over there, but again, I can share it on the chat window after or after our chat is done in general, but you can follow along. Where is Curiosity and see over 8 years, basically, it has traveled 25 kilometers inside a crater. And now with Perseverance, because it has actually landed, you can also start to follow along on where Perseverance is going. Perseverance has a helicopter attached. I didn't talk about that. Ingenuity, in the next few days or maybe by next week, they're going to test running the helicopter remotely. And so we will be waiting to see how that goes. And finally, if you want to try, classifying, kind of working the way that the rovers do or mission control does, there is a really good website called Galaxy Zoo. Again, with your parents, everyone will need to log in, have a free registration, get a login detail. And once you're in there, you can actually start doing some AI work like artificial intelligence and working on Mars data. There's another one called Planet for terrains, which also asks you, you can be citizen scientists and you can start classifying what the surface of Mars looks like, just looking at images that have been taken. So there are many, many ways that you can essentially participate yourself, even if you've just come to hear about what is happening with Mars. I think it's a fun way for you to get in and work with that data as well. So with that, I am at the end of my talk. Apologies, it did go a little bit over, but I'm now going to stop sharing my screen and I'm happy to take some questions. Ooh. Okay.
Okay, so that was a wonderful talk by Dr.Bhairavi Shankar. And now we're on to our Q&A session. So I will just pull up the chat window and see. I'm going to scroll up just a bit because there might be some questions back. People are having discussions and debates in the chat about topics. The one that I saw was how tall Mount Everest is. Okay, so the first question is, why did they name it the Curiosity rover?
So you know what? I think that was a competition NASA put out and asked kids like in your age groups to kind of come up with names. And so I don't know what the exact reason was, but my guess is a student, just like one of you had mentioned, like it's the idea of being curious of what a new surface has, right? And wanting to explore it. So my guess is that's why they went with the name Curiosity.
Okay, so the second one is Mars like a desert?
There are some regions that are like a desert. I mean, it won't get, temperatures on Mars are quite extreme. So you can have minus couple hundred degrees Celsius to a few hundred degrees above Celsius, like 0, right? So it's not like deserts on Earth can get up to 50 degrees. That's still hot. But yeah, there are areas where it's quite dry. So as much as there is search for water, that water has now escaped. Either it got rid through the atmosphere or it got trapped into the rock. So there isn't much moisture, really speaking. And so, yeah, there are parts of Mars that are very much desert-like.
Okay, so this one's a good one. Is there any reason that the moon and Mars have many crater impacts?
Great question. Okay, so that has to do with just what happened in early solar systems. So think about it. We all know that our solar system formed from soupy material. So we had the sun, soupy materials, all of that started to kind of coalesce, like bump into each other. And over the course of, centuries, billions of years, it formed into planets. And then you had other materials that were maybe forming into moons and stuff. But there was still some rocks that were kind of loose and floating around. And anytime a space rock is moving close to a planet or a moon, that body's gravity will pull it in, right? So anything that's coming in, if it comes with some speed, it's gonna hit. So on the moon, you have no atmosphere. So actually, I should take it one step back. On Earth, we have an atmosphere, and that atmosphere has actually helped us kind of break apart these large space rocks or even small space rocks. So think of a rock coming through the atmosphere. The atmosphere is kind of creating friction, and that starts to break apart the rock. So if you started with a kilometer-sized rock, by the time it makes its way down to surface of Earth, it might be 50 centimeters because atmosphere has actually managed to break it apart. On the moon, we don't have that. So anything that hit the moon, hit. And that's why you see so many, like someone has counted the number of craters, but it still keeps happening. There is no end of any sort of meteorite bombardment happening. It could happen microscopically or macroscopically. So similar idea, every solid surface in our solar system has been bombarded. Now, how much of that can we actually see? Depends also on how much has been changed after. So maybe volcanism happened, lava flows happened. That might have covered some of the craters. So we don't have that evidence anymore. Can I get a guess in the chat window? Does Earth have craters? Question 1, maybe send a reaction, like a clap or a thing. Do we have craters on Earth? Yes or no? And if you think we do, how many do we have on Earth? Think about it. I talked about the size of Earth and I talked about the size of Mars. Moon is somewhere smaller than both. So thinking of all of that, how many craters do you think are on Earth? Let's hear a couple of numbers. Safal, I don't know if you're seeing some numbers in there, but
I mean, most people say yes. I'm not seeing many. Oh, well, someone said dozens. Shana said 15.
Okay. All right. Is that it? Is a general consensus?
Oh, we got numbers like 120 trillions, 30.
Okay.
190.
Okay.
Gazillions, 64.
Okay.
190, 120. There's a lot of 190s and 120s.
Okay, so maybe you have heard of this or maybe had some gut reaction to say maybe 190. But for those who don't know, we have about 200 craters identified on Earth. The closest one to us in Ontario, or at least GTA, because I presume most of us are from GTA, is Sudbury. Sudbury, Ontario is a crater. It's just a very large crater. In fact, it's the third largest crater on Earth. And it has actually, it's no longer circular. It's been squished and made into an oval. So different reasons for all of that. But I will say Earth has craters. Yes, Earth has 200 craters. And if you're thinking, why only 200? Couple of reasons for that. There's a lot of water. So if anything hit into the oceans, we don't know that it hit, right? If something hit into into ice, maybe it didn't make that deep of an impact, so we don't know. And then the next thing is on Earth, we have a lot of vegetation, lots of greenery. So imagine if you had a blanket over a crater. Can you spot the crater? No. So it's often like you have to go and see the actual rocks to then be like, maybe this is a crater. And so in all of that process, we have only identified 200. So, okay, that was about craters. So hopefully that gives you context to why does Moon and Mars have so many craters. There's just a good record of it and not much of it has been eroded or destroyed from any other like other phenomenon kind of thing. Okay, what next?
Okay, so this one's also a good one. Is there anything like an ozone layer in the atmosphere of Mars to protect humans from UV rays?
Great question. So I'm not totally sure that there is an exact layer just like the ozone. So this is why one of those reasons is if we want to send humans, we have to figure out where are they going to go and live. So it may not be on the surface. You may have to build a habitat. But imagine if you're humans and going on Mars for the first time, are you going to go with your habitat in place or do you have to build it while you're there? That will be one question. If you have to build it while you're there, where are you going to stay in the meantime? Because you got to protect yourself, right? Right. So I'm seeing a build it. Yeah. So in the time that you're waiting in order to build and maybe get the resources, you kind of have to have caves. So find caves because caves will do what? It'll protect you. It'll keep the sort of light and any sort of radiation far away. So this is where all of the satellite pictures can help us find out where are the caves? Where are these areas where we can insert, like maybe rappel down a little cave system, protect ourselves from the general environment and still be able to plan and be like, okay, fine, we got to, start building our resources and build our habitat. So I think hopefully that answers the question.
Okay, so this one is, how can we tell if there was or is life on Mars?
Okay, so the life on Mars is, it's a bit, we're not, when we talk about life on Mars or any sort of part of our solar system, it's not complex life like we identify, like humans and stuff, right? It's just some of the very basic forms of life. It could be microbes, it could be singular, multi-cell, single cell, multi-cell, etc. Like all of that. There is a whole region, there's a whole stream called astrobiology that looks at the topics of life in space. But the idea is that Mars had warm temperatures. There was a lot of water in past. It's no longer there right now. But if it was there in the past, based on what we know on Earth, there is often reasons and sort of evidence of seeing that form of life. Maybe it can be like, things that are excreted from organisms will leave behind a little like deposit. Maybe can we see that? What does that look like? Is that something that is carbon rich or oxygen rich and things like that? So this is where that whole question about life on Mars is still intriguing, because even if we don't see it right now, there must be evidence of what it might have looked like before. So, okay.
So this one is, why do we have the moon?
Why do we have the moon? Good question. So the moon is actually, so you know what, if you were wondering, does every planet in our solar system have a moon? It doesn't. Mercury doesn't. Venus doesn't. So our leading idea of why the moon formed is, again, early solar system. Earth has just formed, so it's not even solidified crust. It's still like molten, liquidy crust. But very early on, we think that a Mars-sized asteroid or something like an asteroid came a bit too close to Earth. And in that process, it wasn't a head-on collision. It was more of a side bumper collision. So you can think of like, if this is Earth and there's a like little small Mars-sized object, even if it happened to graze by, it still managed to shave off a part of Earth. And once that got released, it started to cool down, and over the course, it became a satellite, so a moon. So this is one of those early hypotheses and leading hypotheses of why Earth has a moon. It was a bit of a collision.
So the next one is also like similar to the other question, is why do we have the sun?
Oh, well, a sun is a star. So if you think about it, I mean, if not this sun, there are other suns. There are different galaxies. There are stars that form. And what we're able to see now is that stars have they have their own growth spurt, right? Like you start as a baby, but then you grow as to, you go into middle age, and then you get older. Stars do the same thing. And so for our sun, we're almost at the middle age. So you can think of parents or grandparents age group. We're at that point. There's still some time before the sun eventually ends. That's easily 5 billion years from now. But because of the sun being there, it is the source of energy, of light. And in that process, there is a solar system that is orbiting our sun. We're not the only ones. We have other solar systems that are out in other parts of our galaxy and other parts of other galaxies. And now we are starting to also have missions, or I mean, not starting to, we have had missions over 20, 30 years that are looking at different parts of our universe to see how frequent are these, how are these solar systems looking like. Interesting fact, and no one knows what the actual reason is. We're able to see Jupiter-style planets, so you can think of how big Jupiter is. We're seeing them at the orbits of Mercury around other stars. So you can think a huge planet so close to its own star. Why is that? And that's one of the big questions that they're still trying to figure out.
Okay, so this one is, why do we have life, and what is the first form of life?
Oh, so you know what? I'm going to mention that I can't fully answer that question because I am not a biologist. And so I don't have that expertise to say what is life or what is the first thing. But I will say, let's see if we can find an astrobiologist to answer this question on a future chat.
And if we can't, there's always you can go to the NASA website. There's a lot of information out there.
There's some, and NASA websites can get pretty detailed, as in you open one link and then it takes you to another. And so good luck, and it'll take some time to navigate through all of that.
I'm skipping over a bunch of these because there's so many discussions happening here.
Okay.
What are they planning to survive on Mars?
Sorry, repeat that?
What are they planning to survive on Mars? Aditya, can you elaborate on that question?
In the meantime, maybe we'll take another question and come back to this.
Yeah. Okay, let's see. What is the next one? Why does Saturn have a ring?
Great question. Okay, so So the leading idea of why Saturn has a ring is you can again think of an asteroid that happened to come so close to Saturn, but it couldn't remain as a whole sphere. And so the idea is that some body came so close to Saturn, but Saturn's tidal, like gravity, was so strong that it actually was unstable. That asteroid or piece of original rock was unstable, and it actually broke apart and then became the rings. But some of those ring materials kind of bumped into each other, and so over the course of, again, billions of years, it has managed to essentially have different regions of rings. So Saturn doesn't have just one. There are about 5 sets of rings, and each of them are very different. So
this one is, why is Jupiter so big?
you know what? That's solar system dynamics. At the start of our solar system, when all of that soupy material was orbiting and cooling down, Jupiter, at the place where it was, I guess that happened fast enough that it could grow as big as it did. It is the largest planet in our solar system. Mm-hmm.
This one was, why did they end up categorizing Pluto as a dwarf planet?
Ha! I love this question because it helps me justify what they did. So it has to do with what is a definition of a planet. So there is usually a committee, and basic definitions of a planet is it needs to be orbiting a star, and it needs to be a circular, like a spherical object, and it needs to have cleared any debris, so any loose material around it. That's the basic definition of a planet. When this whole topic of Pluto came up, of reclassifying, there was a discussion group, and they were like, if we have to keep Pluto in here, we have to include 3 other objects in our solar system that match the same criteria, because they're also bigger than Pluto. They're orbiting our sun. If we're keeping Pluto, why should we not keep those planets, right? Those objects. So it was either you include those, so we would not have 8 planets, we would maybe have 12 or 13. Who wants to remember 13 planets in our solar system? It was either that, or realistically, Pluto had not cleared out any of the debris around it. Earth has, all the other planets have, but Pluto still has some of that material around it. And so they couldn't justify it being a planet. They said instead it's a dwarf planet. And this is why Pluto is no longer a planet. But I will say, from missions, we have still considered Pluto to be an important part of the family. And so we have sent missions to go and explore Pluto. New Horizons mission, I don't have a picture because today was all about Mars. We have taken pictures of Pluto, and we're amazed by what it shows us. It also tells us what's happening in that part of our solar system. So there is a lot of information that we can get about the outer parts of our solar system. What does it look like? What is it made up of? What are those rocks? We know of asteroids. Comets come from that part. So it's not a dead topic. Everyone in the community still wants to explore and go beyond Pluto because it tells us a bit more about that part of our solar system. Okay, go ahead.
So this one is, did NASA dig down to the core to understand the layers of Mars? Or if they haven't, how did you know that?
They haven't. So this is a combination of just understanding, planets in general. So every planet tends to have a same structure of a core, a mantle, and a crust. Now with the gas giants, we don't have an actual crust. It's just layers of atmosphere. So it's a combination of knowing that. So we knew that going in. But then you look at the rocks, the composition of rocks, again, from satellites. Even if you have not physically visited that, you can still get that compositional information and essentially start to build a map of, okay, if I'm here at the surface, how far down do I need to be in order to have rocks that are of this kind? And how do we know all of this? We compare it to what we know on Earth. Again, on Earth, we have good access to these rocks, right? Like, so we can take them into the lab, we can figure out what the composition is. So what we learn about Earth, we apply it to other planets. And similarly, what we learn of other planets helps us understand what happened in early Earth, because we don't have that record either. So.
Okay, so this one is cutting back to the Pluto question. What does Pluto actually show us? So like, what information have we gathered?
So, hang on. I want to now find the photo because it might be easier. But maybe not. I'll keep it for the next time I chat about showing a picture. But basically, Pluto has areas that look like mountains. It has a very thin atmosphere. It has layers of ice, methane as gas, and it has water as well. So it's not as cold and it is cold, but it's not as dead a planet with nothing happening. There are impact craters on Pluto as well that have been observed. There's this whole area that looks like the shape of a heart, but it's actually some sort of like desert area, a cold desert. Imagine, we know of deserts for hot regions, but it could be a cold one as well. And Pluto's moon is about half the size of Pluto. No other moon is in that ratio. So why does Pluto's moon have, why is Pluto's moon that big? And it's not just one moon, there are 7 others that are also orbiting. So there's a whole lot that we know about Pluto thanks to this mission.
So this one is, how far has a man-made spaceship traveled from Earth? So like, what's the farthest distance?
Okay. So I don't know numbers. Don't hold me to that. But the Voyager missions that got launched in 1970s, Voyager 1 and Voyager 2, imagine 1970s is what, about 50, 60 years now since, no, hang on. My math is also not on point, but yeah, so about 50 years. And now in the last maybe 5 years, we got word that Voyager has officially left our solar system. So it still has instruments. It's still able to contact back to Earth. And it has said, bye-bye, I'm going out to the next part of our universe or our galaxy, but it has left our solar system. So
I meant like how many, like in a spaceship with people, not like a satellite.
Oh, okay. So we have the International Space Station. So to even reach there, you could send 4 to 6 people. So we've sent those many, at least at a time.
I was asking how far, like, would a spaceship with people would go? Like, what's the furthest they have went?
So we've gone to the moon. That's the farthest. But that was also in the 1960s to early 70s. After that, the farthest we've gone is 400 kilometers above Earth, which is the International Space Station. So that's why there's all this interest to go back to the moon and to also then eventually go to Mars.
Well, wouldn't the moon be the furthest? Like if you go to the moon?
Wouldn't the moon be?
If you put spaceship to the people, wouldn't that be like the farthest a spaceship with people have went?
The moon is the furthest so far, yes. Yeah. All right. I'm seeing all of the, the chat window is just going. Okay.
Oh my. Okay, so this one is it possible for a lander to go inside Jupiter?
Not a lander. So there have been orbiters and flybys, but a lander has not gone on to Jupiter. They want to send a lander to Jupiter's moons. So Europa or Ganymede. There is a lot of discussion and interest in sending a lander to the moons of Jupiter, only because the moons are telling us something unique. There is an icy crust, but beneath the icy crust, there is also an ocean. So they want to go and explore that because, again, with oceans, maybe when you're closer to the core, it might be warm enough. Is there life out there? All of those questions.
Okay, so this one is, can Mars be seen from Earth with a telescope at night?
Yes, it can. And I will say when the pandemic is over, I will encourage you to look up the Royal Astronomical Society of Canada. They're an astronomy group. They have a center in Toronto. They have it in London. They have it in Mississauga. And Mississauga, I think, serves Brampton as well. They usually, again, when the pandemic is over, they would have like star parties where their members will bring out the telescopes And if Mars is in view, you can see Mars. So I will defer to them.
This one is, why does Saturn have 54 moons?
You know what? That's to do with Saturn, its size, the fact that its gravity can pull in a lot of things. And so similar to what I mentioned earlier, when an asteroid is coming close to a planet, if the planet's gravity tugs onto it, it pulls it in. And so Saturn has done something like that. And we are now at, I believe we've gone well past 60. But yeah, there's many moons.
Okay, this one is, why do we have the Earth?
Earth is a planet that formed just like other planets in our solar system. So it's just why Earth ended up being the way that it is. It's still trying to figure out, because we have tectonics, plates are moving. So this is where we have different continents, we have the ocean. Some conditions helped for trees to grow, and we have a lot of water. And so Earth is the way that it is, but it's also just a planet in a solar system.
Okay, so this one is, will Mars in the future have rings like Saturn?
Probably not. Again, if anything were to have happened, it would have already happened early in the planet's history. Now it's just been there for so long, it's kind of clearing up, right? Its own debris and things like that. So my guess is not.
This one is, what is what is Mars made of?
So remember I had that picture with all the different layers of Mars. There is, so Mars, basically, if you look at the rocks, it has some aluminum, it has some silica, but it has also some iron. That iron has come from inside of Mars. When these volcanoes were erupting, they were all very rich in iron. And so some of that iron got trapped into the rocks. And so this is where the Mars rocks are pretty much iron rich. And again, kind of like the rocks that we see on Earth. And might have some water trapped in there too.
So, oh, wait, that was the next question. Is there some water left on Mars?
Yeah, so all of these missions have been looking for that. So there is water. It's in the form of maybe some snow in certain parts of Mars. It's like beneath the surface. It's in the form of clouds in parts of the Mars atmosphere. And a lot of it is actually trapped in those rocks. So there is water. It's just, you kind of have to find it.
So Earth will ask, what is the ozone layer?
Okay, so I'll do my best in explaining that. The ozone layer is this layer in our atmosphere that essentially forms a bubble, and it protects us from getting all that solar radiation to hit the ground on Earth. And so the layer is a bubble. It again protects our skin. We don't have to deal with any of the effects of solar radiation. But I think there have been, man-made influence that has started to cause a tear in that layer. So imagine if there's now a hole, some of that solar radiation can get through, which means that it will not be safe for humans to be exposed to that radiation. And so the ozone layer is very important to protect, to make sure that tear and that hole is not too wide. And this is where governments and society have ensured now that the products that are being made are not going to help cause that tear in that layer. This is the simplest way to explain what is the ozone layer.
Okay, so this one is, I'm pretty sure you mentioned this in your presentation, but how did Mars get its red color?
Yes, so the red, again, I mentioned the rocks are rich in iron. When you have iron exposed to the elements, be it water, be it air, it gets rusty. And so the redness is from the rust. Okay,
this one is, what was Mars like in the past?
It was very warm. So again, there were periods in Mars's history where it was quite warm, it was quite wet. If you remember the map that I showed topography in the southern parts, there was a lot of channel rivers and things going. So there was evidence that water was free flowing. And so it was nice warm climates, but it has since escaped and disappeared.
Okay, so I don't see any more questions. but we do have 3 people with their hands up, I think.
Ah, yes. Okay.
Okay, so, oh, there's only one now. Okay, Vijayan, do you have a question?
I'm gonna take some water.
Okay, hold up. It is.
Can you say the name again?
Oh, I'm pretty sure I pronounced it wrong. I'm so sorry. It's Jian, Giyann.
That's me.
Okay.
I wanted to ask how I have heard like Jupiter, it has so much gas in it. So is that true?
Jupiter is made up of gas. Yes. It is a gas giant. It has all kinds of gas like nitrogen, oxygen, anything in that we know from our periodic table. Jupiter has it. And in fact, instead of a crust, the layers of gas are what form the atmospheres, and there are different layers. So there are storms that happen. So imagine if you were just living in clouds, there's a lot of storms and things. So Jupiter is very interesting, unique. It's the largest planet in our solar system. And I will say, look up if you want to learn more about Jupiter and its atmospheres. There is a mission right now going on called Juno, Juno. And it is in charge of just taking pictures of that atmosphere and helping everyone understand what are these layers? Why is it the way that it is? How fast are they moving? You have storms, right? Like you've heard of the Great Red Storm Spot. What's that? And so there's quite some interest and research happening.
Okay, so this one is, when we go on Mars, will we stop aging as much because there is less gravity? Because everything will be slower.
The aging, yes, you will be younger on Mars than you would on Earth. But there's a whole set of reasons for that and how long, and it's not, sorry, can you repeat this second part?
Okay, so it is, when we go on Mars, will we stop aging as much because there is less gravity because everything will be slower?
There's the everything will be slower part is true, but that doesn't mean that you're automatically age. I mean, you're aging at the same rate. It's just when you're on Mars, you're not as old as you are when you're on Earth. If that helps kind of put it in context. But yeah.
Okay, so we have some more people.
Sorry, I'll just add, it doesn't have anything to do with the gravity. That's unrelated.
Yeah. Okay, so we have some more people with their hands up. The first one is Aline. Or did you type it in the chat already?
I already typed it in the chat.
Oh, okay.
Sorry.
That's all right. Okay, I see Vinayak, or I did see Vinayak, but I don't see anymore.
Last one's Free.
That's not my real name. But my question is it true that on Sun the gravity is pushing against it, and at the core it's pushing outwards, and it can burst into a supernova?
Okay, there are a few layers in there, so I'm going to peel them off a bit. So with the sun, basically what's happening is fusion process, right? So your hydrogen is getting converted into helium. In that process, it's keeping it like a balloon kind of floating. It's like sun's own gravity could consume everything, but because of this reaction process, it's helping it stay it's not condensing or not falling into itself. So that's one thing. But over the course of time, that hydrogen is going to run out. So what will happen eventually? Sun's gravity will take it over. And so it'll eventually collapse into itself, but it'll not just like disintegrate or do anything. It'll become a smaller star. And for the size that the sun is, just because of the way that it started off at, we're never going to reach a supernova stage. So it is more like the sun will, in that process of trying to fight what it wants to do, is the sun's gravity going to take over, or is this reaction going to happen? So hydrogen goes to helium, but then helium goes on to the next set of reactions. And in that process, the sun is like, what should I do? It'll balloon first. It'll become a red giant. In that process, it'll balloon to the point that Mercury, Venus, and Earth will no longer be there because it has become that large. But then eventually it can't sustain and be in that same spot for long. It'll condense back. And that's where at the very end, the sun will become what's called a white dwarf. That's just the kind of star that remains at the end of a star's life, kind of thing.
A dwarf
But you
star.
need to be super big to begin with in order to become eventually a supernova, or maybe some supernovas eventually get into a black hole, but that's not our sun.
Well, would it
Study a lot of space.
Would it
Well,
what?
I like studying about space.
Awesome. Me too. It's fun. There's so many different aspects about what you can do. And every part of STEM is really, you can find it in space as well, right? Like geology, chemistry, biology, engineering, physics, all of that is all part of space as well. Oh, yes, I see one wavy hand. Hang on, I can't find your name. There says iPad. Go ahead.
When the sun becomes a black hole, how big will it be?
Sun's not going to become a black hole. Remember, I just said the sun is going to end up as a white dwarf. But black holes are found around other stars. And so they are of different sizes. And I think that's where the community is still trying to understand how big black holes can get, where they are, and things like that. But our sun's not going to become a black hole.
Okay.
So this. Oh wait, no. Go ahead.
Well, don't you need what? So I heard that you need a star 10 times as big as the sun to create a supernova.
Not just 10, I would say larger than that. And there's a whole, if you look up the word on Google or on YouTube, it's called main sequence stars. Or even National Geographic has something about like star formation. I think they do a really good job explaining the basics of stars, what they are, how big they can get, and then really how what happens to them at the end. Because yeah.
And also I heard something called a hypernova, and I have no idea what that is. Like,
I don't know that I know it either, like fully. But yeah. Oh, I see 3 more hands up. Okay, so in the last 7 minutes, we're going to take all of these questions. Okay, so let's go with Felix, as I see it on my screen.
How will the sun become a white dwarf? Like, will it get smaller?
Yeah, it gets smaller.
Yeah, but how will it get smaller?
There's something known as, it's sort of the star evolution. So for the size that the sun is, it first becomes a red giant, so it balloons. But then over time, that ballooning cannot sustain itself because sun's gravity is super small and it needs to collapse onto its own. And so I mean, it's not the best way to describe it, but think about how, again, it's not the best way, but the simplest I can think of right now is like you blow a balloon, right? But if you don't tie it and you let it go, it starts to expand, but then eventually fizzles out and lands, right? You can think of like our star doing something similar in that it grows first, but then it eventually just collapses into a white dwarf. So what's left is just the core of our sun, and that's known as a white dwarf. Okay, thanks for the question. I see one, Ritu L, grade 2. Do you want to ask your question?
Why is Uranus and Neptune called ice giants if they're also gas giants?
Because they're gas. That's very true. They are pretty large. They're larger than Earth or Mars, but smaller than Jupiter or Saturn. But they're called ice giants because when you're that far away from the sun, the temperature is super cold, that everything, even if it has gases, it's like iciness. And so that's why those are known as icy giants.
Okay.
Okay, thank you. Okay, next I see Vinayak is back, grade 4.
Yeah, I have a question. What happens after the sun becomes a white dwarf?
It just stays like, it's a star that doesn't give off any energy. It's just, you can think of it as a static star. Nothing much is happening. It's just there for the end of time. So nothing happens. It just stays there. but it's not giving off any light. So you don't see it, but you can sort of you still know that it's there.
Yeah, and what happens to the other planets like for example Mars and Jupiter? Like
I think they still stay as they are. It's just now because you've kind of lost your first 3 planets. I'm not sure like how that affects the dynamics of it, but my guess is they still stay as they are. But I mean, who knows? Maybe in that whole red giant phase, it might have done something. It's not like they get destroyed. It's just they just remain as is.
Oh, so they won't like float away if they're not like.
No, because your white dwarf still has some gravity, so it can still hang on to things. It's just it's not functioning as an active star, right?
Okay.
Mhm.
Thanks.
Sure. Okay, Ameya, I see your hand up. Do you want to ask a question? Ooh.
It's gonna lower.
Oh, I couldn't hear that.
I think you're on mute.
Why does Pluto is a dwarf? Why Pluto is a dwarf planet?
Oh, I'd answered this a little while back, but basically Pluto is no longer a true planet because it still has some things around it that should technically have cleared off. So think about like if you had a planet and some little rocks around it, to be a planet, you had to clear out all that rocks. And if it's still there, it's not a planet. And that's why Pluto became known as a dwarf planet. So it's almost there, but not there.
So I think we have time for like one more question.
We do. So let's see. I see Praveen. Did you have a question? Go ahead.
Yeah, I just want to ask, how I don't think scientists know much about it, but how is a black hole, a white hole formed, and is it like the opposite like of a black hole or something?
You know what? I don't know it myself, so I don't know that I can answer.
Well, I did hear that white holes are the opposite of black holes. Instead of sucking things in, they spew
They
out.
reject it.
Yeah, that's what
I
I
will find out more from an astronomy friend and confirm that, but I won't say that I know all of that or have the expertise to answer that question. So let's ask an astronomer.
And there's about 5 with at least 100 galaxies. A satellite, I think from 19 something, found a lot of galaxies and sent it to Earth.
Like this, it sent the data to Earth. Yeah, there's like the Hubble started off, but then you have Kepler, then you have, and now in later this year you'll have the James Webb Telescope, and they're all looking at different parts of our night sky and seeing if there are other solar systems, what kind of stars they're around, are there black holes, where are they? And so between those missions and telescopes on Earth, yes, there is a whole community that's looking at all of that. Okay, we're at 6:30.
So that's basically the end of our session. Everyone, give a big thanks to Dr. Bhairavi Shankar for talking to us today.
Thank you,
hope
everyone. I loved the questions. There have been a lot, and I'm seeing like I've not seen the chat fully, but I'm sure it was quite active.
We have a lot of inquisitive people here.
That's not a bad thing. Yes. All right, but nice to meet everyone. Take care. And enjoy the rest of your break.
Okay, thank you, Dr. Bhairavi. Thank you.
Bye.
No
and
problem.
Thank you everyone for joining.
Bye.
Bye. See you tomorrow.
Bye.
Bye.
I saw some few familiar faces. So I'm like, oh, I remember them. Yeah.